Greetings from BSMA. I am Devendra Mishra, the Executive Director of BSMA, and it is my greatest delight to be able to bring to you three great stalwarts that will focus on this subject titled Unlocking the Power of AI, Artificial Intelligence, in the BioPharma supply chains. Before I introduce the subject matter experts, let me share a couple of housekeeping routines with you. Number one, the entire recording of today's session, the video recording, the audio recording, will be made available to all those who have registered for the webinar, probably within a week. Number two, we welcome a lot of questions that you may have, but bring them to our attention in the last 10 to 15 minutes of the webinar. And more importantly, do not use the chat button at the bottom of your screen to send us your questions, but use the Q&A iconic button at the end of the screen. And if we don't get to all your questions today, I promise you we'll get back to you with answers down the road. But do save your questions for the very end, for the last 10 to 15 minutes. Regarding the panelists that we have today, Rich Kilmer is the president CEO of CargoSense, a pioneering company that has made software as a service available to all of us to monitor the transportation network of not only life sciences, but also of the food industry and the medical devices industry. I know of no other company today in the United States that is as committed to providing intelligence, providing smart decision-making capability in an AI-driven world. He just makes it so easy for even dummies like me. The number two, my colleague, Dr. Siamak Zadeh, 30 years of experience in industry and academia, beginning with IBM, Oracle, Axway. He's finally the associate professor at the Golden Gate University. He is the chairman of the AI initiative, and obviously you'll learn a lot about him during the webinar. And saving the best for the last, because it is the younger generation that's going to lead us forward, is my good friend Vikash Jethmalani, who's a graduate student at the Golden Gate University. He just happens to be also the president of the AI club at the university. But more importantly for me, he is a brilliant researcher on AI. So, ladies and gentlemen, I turn it over to my good colleague, Dr. Zadeh, to kick off this webinar. Dr. Zadeh.
Devendra, thanks very much for your kind introduction, and hello to all our participants in this webinar. Allow me to share my screen and share some of the slides that we intend to use as mostly a placeholder for our communication with you all today. As Devendra mentioned, the intent is here to provide you some just basic talking points and terminology as we try to demystify the emergent powerful AI technologies, the more recent ones as that. So I would go over the very brief review of what it really AI is, just to make sure everybody's on the same page. The intent is not to do a deep technical dive as technology. As Devendra mentioned, we'll be more than happy to answer any questions, go further into depth of any topics as we do, but just to set a stage for my colleagues, VJ as well as Rich, when they're going to be doing some demonstration on the capabilities of technology. So let's start by just reviewing what is the latest thinking of what AI is? AI, as you probably are fully aware, was coined in 50s. So it's been around for a long time. And its definition, its concept has really evolved throughout the times. It's just the last few years that it's just got such a massive attention as a lot of enabling and underlying technology that are now really our subset of the broad umbrella of AI have come together and converged primarily machine learning, deep learning, natural language processing that really have come and converged in a text domain and processing, leading to the emergence of these large language models, generative AIs. And it's continuing to evolve. The last few years, the convergence of these technologies have kind of created a quantum leap into its capabilities, its promise, application, hence the buzz, and hence, based on all the reports we are hearing, that significant contributions to the growth of our GDP in the last few years has been due to the emergent AI technology. But the buzz really started out late 2022 when the whole concept of generative AI, ChatGPT platform, and other platforms emerged. There really was the convergence of these text processings, vectorization of the text processing activities, tokenization of them, and creation of these engines behind them, these large language models, which really allowed for a semblance of reasoning based on the convergence with the neural networks technology that look very much like our human mind and our cognitive capabilities. That was a game changer, not only for AI as it evolved over the past 50, 60 years, but also for its application to industry. And that's been the buzz since then. And as we're continuing to advancement of it, the large language models, as well as the latest trends of these technologies, are going to be continuing to set the agenda about how it's going to be applied. Let's take a look at really what is the large language models or Gen AI technology stacks. It is a very multi-layered modular. The entire advancement in AI is due to proliferation and explosion of data. So without data and without the advancement that is happening in the underlying infrastructure with the Internet of Things, with the proliferation of sensors and data coming from every direction, the advancement in AI would have not been possible. So AI really is at the foundational level of the all these large language models, generative AI, and more recently, we're going to see with the latest trend known as agentic AI. Then the most recent advancement in the AI infrastructure, from the data centers we are hearing, from data lakes, from the emergence of the new technological advancements on all various aspects of computing, primarily on the graphic processing units, with companies such as NVIDIA that really is revolutionizing the AI infrastructure of it. And then the advancement of these models that are emerging. Of course, there's still a very big debate in the community whether we should go with the proprietary models, whether we should go with open source models. And these are the conversations that later on, when we do some demos, we're going to talk more about it. But the primary focus now is what is this going to do for in a specific business? In our case, what is this going to be able to do for the biopharma supply chain in particular? So we're going to be looking at really more of the application layers, especially this most recent trends, which is called the agentic AIs or AI agents. But before we do that, let's just make sure we all have a clear understanding what large language models are. Large language models are really are these research models that were trained on vast amount of text-based knowledge, adding to them a methodology for data pattern recognition and additional reasoning from inductive reasoning to deductive reasoning. So ultimately, one view of these large language model is that they're really a reasoning engine based on the data they have been trained on. And then the predictability capability they have. Of course, they're not without flaws. I'm sure most of you have heard that the concept that a lot of these large language models could produce wrong results, what is referred to in the industry as hallucinations. But at the same time, they do provide significant benefits and values as we're going to do that. So they are ultimately a probabilistic reasoning engines that can be utilized in a proper context with additional guardrails to ensure proper use, responsible use, at the same time, very effective use and avoid the risk that some of those flaws may offer. But more importantly, now we're entering within a couple of years' time, that's how fast this space is advancing into a new trend known as agentic AI or AI agents. So, what are AI agents? AI agents really are a very simple autonomous software that are based on this LLM, but very focused on a specific tasks. So it's very interesting that within 2 years, a generative AI and chat GPTs are still very popular. And the concept known as prompt engineering that just came out in the same couple of years' time, it's now yielding itself to newer trends. And that's really one of the key points, takeaways we like to have from this webinar, that the whole AI space is evolving, advancing rapidly. So keeping up with it becomes essential, especially when it comes to application to variety businesses. So in a nutshell, AI agents are a software component that they have what is called the concept of an agency. They have both the responsibility and the authority to act on very specific tasks. And this is where the benefits of some of the conversation we're going to have later this today brings to the supply chain, that by understanding the diversity and variety of specific workflow, enterprise workflows, transactional activities that happens into entire domain of biopharma supply chain, we could identify a variety of these AI agents that are very task focused, task specifics. And then one of the benefits of them, that as we're going to be having more conversation about, is that much smaller footprints than leveraging those large language models. So one of the benefits of AI agents is that it can focus on a specific task and not try to boil the ocean across for every activities that we'd be doing. It is very autonomous. It can be designed to act based on the information it receives, and more recently, the ability that they are can learn from their experience by collecting more data and go through a self-learning and revision exercise and update themselves. So adaptability and the capabilities they offer, especially conversational capabilities that we're going to be looking at, and all are becoming very important tools that can enable and augment and enhance a lot of activities that we could do in supply chain. So let's take a look at a few areas before we go into the specific demos and conversation we're going to have, how AI agents can help advance the business needs and address some of the challenges of the biopharma supply chain. They can create an autonomous supply chain planning. They could create AI agents that autonomously predicts demand, optimizes inventory, and plan production without our human intervention. Of course, as a augmentation enhancement of capabilities. There's no intent here that any of these AI agents would be replacing any activities, rather than would be enhancing, augmenting, supplementing them with the intention of optimizing whatever the enterprise flow is that and provide information. Cognitive procurement agents, we could create agents that can negotiate with suppliers on behalf of the various stakeholders here and leverage the fundamental technology, which is enabling these agents, such as natural language processing for negotiations and intelligence contract management and sentiment analysis. We could have an AI-driven logistic optimization. We're going to actually talk about it more extensively with some of the demos that my colleagues are going to show you. And we're going to see some of the real-time supply chain visibility and risk management. These are just a few areas. We're at the moment scratching the surface of the opportunities that the advancement in AI, particularly AI agents, can bring to the supply chain. The intent of this conversation is that just to hear from you as well as we will continue this conversation further in the future and hopefully with a larger event that we could do more deep dive into some of the areas that these advancements can bring to enhance and augment the current processes in the biopharma supply chain. Let me stop here, Devendra, pass it on to my colleagues. As I mentioned, these are just the very high level talking points that then we can expand on each one of them during the next phase of this conversation.
Thank you, Sia. Vijay, do you want to take the ball from here?
Absolutely. Thanks a lot, Professor Sia, and thanks for the kind introduction. Devendra, let me share my screen. Okay. All right. Okay, so can you guys hear me?
Yes, we can.
Okay, great. As Professor Sia mentioned, AI assistants, AI agents can touch many different facets of the supply chain, the biopharma supply chain. In this short demo, I'll be looking at three relatively simple but extremely powerful use cases. So the first example is this idea of augmenting the context of your AI assistant by using company data. And we'll see that in action in a minute. The second use case is where your AI assistant can actually facilitate data collection from some delivery personnel in the field. And then finally, the shipper or the person handling the shipment um, at the origin can now monitor and map and receive alerts about that shipment in real time and have a conversation with the AI assistant about what is happening with the shipment. So at the heart of all these benefits is the very simple idea that you have an assistant, a digital assistant that has the ability to understand natural language and comprehend natural language. So starting with that first example, let me just dive into this delivery portal. I have to move this aside. Okay. So this is kind of a mock shipment tracker workflow, and I'm going to put in a particular shipment address over here. So okay, hang on a second. Sorry. Okay. So, so with example one, this idea of your large language model having this augmented context based on company data, let's try to ask this. Imagine you have this delivery person in the field, and this delivery person has a question about, notices there's some condensation and wants to call a phone number to get more information about it. So let's say this delivery person asks the AI agent, I have a condensation question. please, can you give me a phone number to call? Okay. So this assistant is extremely fastidious. This assistant has received instructions to not give out any information unless it has very specific information related to the shipment. And so it doesn't have any information about answering questions about condensation. It doesn't have any information about providing phone numbers related to that. So now let us augment the knowledge context of this particular assistant and see how that that improves its ability to answer the question. So these are just company FAQs. So there is now another large language model that is taking this information, taking the FAQs, digesting it, and will be optimizing the output based on that input. Okay, so let's try the same exact question. And so there you have it. So this is a phone number that was embedded in the text. And if I can bring that up, see if I can bring that up. Okay. So here is this short document that I uploaded. And inside this document, let me just move some of these things aside. So the information we got was you can call the technical support line 555-0103. And sure enough, that's the number here, right? And so now you have this large language model that was able to augment its knowledge context and provide useful information to a delivery personnel. One of the disadvantages, or I should say, one of the limitations of an AI assistant is it is based on static data that it has been trained on. And so there is a knowledge cutoff for that particular AI agent. Through the use of this technique, it's called retrieval augmented generation, you can actually provide this AI agent with more current information. Not to mention, you can augment its knowledge context with things like company SOPs, and this was an example of using some company FAQs. So that was an example of like the first kind of low-hanging fruit way in which you can take an LLM, you can augment its knowledge context and provide useful information to a delivery personnel. The second example is with the delivery personnel interacting with the agent and the agent validating some of the responses it gets from the delivery personnel and using some of its rules for that validation. So, and these are rules that, the programmer, the person designing and creating this agent has provided the agent in the form of a system prompt. So in this example, let's say the delivery person types in 4, right? Now the AI agent has been instructed to be very careful with accepting input. So it understands that it's important to not be ambiguous, and you have to be exact in the input that it receives. And so it can, and this can apply for like a variety of inputs from the delivery personnel. You will see this AI agent repeatedly insist on having exact information. So finally, let's type in fact, let's try this. Okay. Let me do this first. Okay, so this falls within the acceptable temperature range. The agent accepts this data. Okay. And everything is fine. So now let me log back in again. I'm sorry, I think I've accidentally press date tool here. Sorry. Okay. All right. So I'm going to type in this information again. And this time I will put in a bad, or I will put in an out of bounds temperature, okay? And keep an eye on what happens in the shipment portal. So the agent now, again, understands that the input from the personnel needs to be within this range from 2 to 8 degrees. And so if it notices that the temperature provided by the personnel is outside that range, it will post an alert. And there it is. So you see now there's been a temperature excursion. The agent notices that, and it alerts the manager or the person monitoring these shipments. And now the third and final example is then again the ability of the the person monitoring these shipments to actually interact with this AI assistant using natural language. So this part here has nothing to do with the agent. It's just a way to kind of map where you are. And so what we'll do here is we'll ask this assistant about the alert. So this has kind of been fancied up a little bit through voice, and so I'm going to do that. So please tell me about any temperature excursions. Thank you. Okay, so the agent understands the question. Keep forgetting to do this. All right, and so now here you have information from the agent, is telling you about the shipment, is telling you what happened, the alert, indicate a temperature reading of 12 degrees, it's outside the acceptable range. I can have visibility into all of the shipments and say, how many alerts do you see across all the shipments? Thank you. Okay. And sure enough, we have 2, 2, and 2, so we have 6 alerts. And so you can basically interact, Professor Sia mentioned there are these limitations where sometimes agents can have hallucinations, and that's true because these are not deterministic models. I mean, there is a way to set the temperature to like 0, and your model can be pretty close to being deterministic. But for the most part, these are probabilistic stochastic models. And so if you talk to the agent, you ask the same question, you will oftentimes receive slightly different answers. That being said, for the most part, as these models get better, their ability to reason and comprehend gets better as well. And so you have now this amazing ability for an agent to take all of the data that has been obtained from the field, maybe company policies that have been uploaded, and digest that information, and then have a natural language conversation with the person handling that information. Here's something. In fact, I think I should leave it at that and hand it off to Rich, who will talk about how you can go even more granular. And so instead of relying on just some delivery personnel, you can actually now use sensors to make sense of your shipments in the field and talk to them. So take it away, Rich. Let me stop sharing.
Awesome job. Yeah, so we've been using the term agent for the last 5 years, I think, when it comes to the use of what we called agentic systems in cargo sense. And so we've been using this, we've been presenting on this and things like that. Like like Dr. Sia said, when we think of agents, we think of autonomous pieces of software that have a responsibility and an authority to do something. And the way we embody agents at CargoSense, not are always are, we don't always embody them using these large language models. I will actually show you some examples of that today, as VJ just showed us in those examples. We embody agents around the idea of specific kinds of rules that we want to make sure that shipments are following. And the agents, at least embodied within our systems, are deterministic. They're very deterministic. They're not using they're using more rules engines, right? Rules engines. And back in the 50s and 60s, when we came up with AI and we were using these terms artificial intelligence, we had two kind of branches of that. One were rules-based systems, and the other ones were these neural networks. We didn't have the computation to run computational neural networks back then. We had the perceptron models and all these things. But we did have rules engines, and rules engines became so common that they're just built into most of the systems we use today and we don't think about it. And then as compute became more and more capable, we've now got these incredibly powerful large language models with literally hundreds of billions of parameters. In other words, hundreds of billions of neurons, if you want to think of them that way, that are creating these responses like VJ just showed us in the demos that he was doing. We just did not have that computing back then, but we did the rules engines. CargoSense embodies a lot of rules-based systems. Sometimes we depend on models that our agents use, what we call like machine learning models to classify things. Like we have a machine learning classifier that will take all the information we know about a FedEx or UPS shipment in North America, and at 9 o'clock in the morning, the agent will wake up on a particular parcel that's being shipped and say, will this parcel deliver today? And it does that for all the parcels where our platform is watching, and that is about 10,000 parcels at a time, right? So we're watching all these parcels. Each time one of these agents wakes up for its shipment and it asks this question of the classifier looks at all the information that it knows about that shipment against this whole model of about 1 million different shipments that we've looked at over the course of time. And it says, based on everything I know on the shipment and everything I've learned over here, will it deliver today or not? Why is that important? Well, if you've got a parcel that needs to deliver within by today, and if it doesn't deliver today, it's going to be too late, right? Because these parcels a lot of times have time limits on them, right? They're insulated, refrigerated boxes, and they have this time limit. Tomorrow will be too late. And so by being able to say, will it deliver today, this day? Well, it'll make a delivery attempt. And if it's no, you now have 24 hours notice to be able to act, right? To say, hey, consignee, when you get this parcel tomorrow, it's going to be too late. We're going to ship you a new one today, right? To replace the product that we shipped you that is arriving too late, because sometimes this happens. So those are examples of agents we use within our platform. What I'm going to talk about today, similar to what VJ did, is I'm going to talk about how easy it is to actually do this stuff. So VJ developed what he demoed today, right? I mean, he went through and he developed the software, and you can do this development. What I'm going to do is I'm going to show you, I'm going to share my screen. I'm going to jump over, not to that terminal. I'm going to jump to this one. And I'm going to go to the terminal. And I'm sorry, but I'm one of these people that still uses the command line, of my computer on my Macintosh to be able to do things. And what I am going to show you is I'm running a tool locally called Ollama, Ollama. Ollama is a tool that you can install on your personal computer. And then you can get at it through a graphical user interface. So Ollama does have a graphical interface that you can use to chat, just like we're talking about with ChatGPT, but it actually downloads the models and runs them within your personal computer. A lot of people are concerned with okay, if we have one of these models like Grok or, ChatGPT or Gemini, and I put in company information out there into that cloud large language model, I'm exposing that information to that model. What are they doing with that information? Now, some of these companies tell us, hey, we aren't going to record this stuff. If you do it within like Gemini and you have the enterprise kind of license there, they'll restrict and sandbox that stuff. But if you download these models to your computer themselves, it's not going anywhere. It's staying in your computer. Now, what I'm going to do is I'm going to start a model here. This is what I call a warehouse model, and I'm just starting it up on my computer, and it comes up with a prompt. I'm going to make it a little bigger here so everybody can see what I'm doing. What I want to show you, though, is this is an off-the-shelf model. It's called Qwen 3. That 30B tells you how many billions of parameters this thing is running on my computer. So this is on my MacBook. I'm running a 30 billion parameter model on here from Qwen 3. And yes, this is trained by Alibaba in China, right? But I'm now running this large language model on my computer. It's not able to reach outside of my computer. This information isn't going anywhere, right? This is a completely safe operation. But what I did was I took the off-the-shelf model and I loaded into that what is called a system prompt. And when you deal with Grok or any of these online models, they have a very sophisticated system prompt that they create. In other words, when I interface with ChatGPT, there is a system prompt they give ChatGPT before you even interact with it that highly constrains what you do. It's going to protect you from things. It's got all these rules. And those things, those system prompts are usually very long and they're called guardrails, right? They protect the LLM for what it can do and things like that. What I'm doing here is I'm creating a system prompt around a domain object in supply chain. And here it is a warehouse, and you can read it. So the current time is 12:25. It's close to that, it's 12:37. My name is Rich Kilmer. Sorry, the user's name is Rich Kilmer. Rich is a ship supervisor at this warehouse and works for United Airlines. You're a warehouse, at IED in Dulles, Virginia. The airport code is IED. You have delivery doors. It has 2 rooms for storage, right? The first room is 15 centigrade to 25, and it's used for controlled room temperature or CRT products. The second room is 2 to 8, and it's for refrigerated products. Both temperature controlled rooms have forklift access with automatic doors that open when the forklift pulls up to them. And then there's 3 shipments here, right? Now, what's really important here is this is just text, right? This is text, and imagine being able to generate this text in real time based on the state of what you know your warehouse is. So although this is canned text that I've typed in here, it's very easy to generate text. And so what so let me go through these shipments. First one is this airway bill. It originated in Brussels. It's scheduled to arrive, today. Air Cartage is the one who's going to be moving it. It contains a temperature controlled product. It should be stored in the CRT room. And this doesn't say the temperature. It says the CRT room, and the shipment belongs to, I'm going to change the look at Merck, right? And then I've got another shipment that came from Paris that belongs to Pfizer, and it should be in the refrigerated room. And then lastly, I've got another one that originated in London. It's got this flight. It arrives at this time. It's running a little late. Expeditors is going to pick this one up, and it should be stored in the main warehouse, and it belongs to Toyota. So just with this system prompt, when I started this over here, what I've done is I've taken a general model on my personal computer and I've loaded that text in here. And now I can say, what time is it? And what it's going to do is it's going to think. And this is what you normally don't get when you're dealing with a chat GPT or something like that. You normally don't get to see its reasoning behind it. But what it's doing is it thinks about this. These are called reasoning models, reasoning large language models. And it reasons through this. And you can see, we are to address him as Rich. So we'll currently say it's currently 12:25, Rich. It's currently 12:25, Rich. Your shift ends. So it actually took my shift information out of there. So you have about 2 hours and 35 minutes. It actually computed that time based on when my shift ends versus what time it is now. And I did not program this response. It actually just spoke that back. How long until the next shipment arrives? and it's going to think, and it is saying, oh, this one's 36 minutes late, so it's reasoning over this. It kind of goes back and forth. It double checks its work, and then it comes back and it says, the current time is this, time until arrival 87 minutes, right? It does the math. And then it says your second shipment will follow later. Your shift ends at 3, so you'll have time to handle this before your shift concludes. Which of these are pharma products? Now, again, it's reasoning over things it's learned. And I did not put this in, but it basically says these two shipments, shipment 1 and shipment 2, are pharmaceutical products. We didn't say that. We just said it's Merck and Pfizer. It intuited that based on, or reasoned through that, based on the fact that it's in CRT and refrigerated storage, and it came from Merck, a major pharmaceutical company, and Pfizer, a major pharmaceutical company, but Toyota's shipment isn't that. So it is able to reason through this, right? And now I can say, what should I do to prepare for the first shipment? Now it's reasoning through what it's going to do. And what it's doing is it's pulling out of everything it's learned to put together steps. And it's saying, here's the critical steps to perform. Now, again, we just prompted this, right? With the information we had before. Number one, verify the rooms at the proper temperature condition, right? 18 to 22 is ideal for Merck's products. Check the room's digital thermostat, fill out the rate, adjust it immediately. Why? The pharmaceuticals fail, right? Confirm the CRT room has access. Ensure that the doors are functional. Action, walk to the CRT room's doors, stand near them, and if the door is open, you're good. But if not, let them know. And then Air Cartage will use the forklift to unload. Not technically, they don't do that. Again, this is a little bit of hallucination. Air Cartage isn't doing this. United Airlines is. But confirm that Air Cartage is going to pick it up, right? And it'll be at the CRT room door. And then do this within 10 minutes. Call of that, and then handle the pickup after. What don't you do? Open the CRT room unnecessarily. It causes temperature spikes. Again, we didn't teach it this. But what I just wanted to show is how interesting it is to experiment with information about things in our supply chains that we can load into these general purpose large language models with just text from something in our supply chain and get back this kind of useful interface. And so you could imagine this allows us to build an interface for dealing with, for example, a warehouse or a shipment. And I'm going to give you another quick demo about this from a shipment perspective. And this is using a different means of interaction. So this was text-based. This next one is actually going to be via my phone. So I'm sharing my phone here. I'm going to bring up a camera on my phone. I happen to have this QR code. We do a lot of cool stuff with QR codes at CargoSense. And what I'm going to do is I'm going to go into the logistics assistant on this. This logistics assistant is a voice assistant. So like VJ showed, this is a question and response voice agent. And what we've done is taken an off-the-shelf voice system, attached it to an LLM, provided a system context around a specific shipment, and I can interact with this agent in this way. This entire thing took me about an hour to prepare and do. So this is not hard, okay? This is absolutely something which people can do without a lot of heavy lifting, with no IT, just to be able to show you this. And I can do it via text or voice. I'm going to do voice. So bear with me here. Hopefully this works.
This is your CargoSense AI Logistics Support Assistant. How may I assist you with this shipment today?
Where was this shipment destined to arrive to?
The shipment was destined to arrive at Gilead in Cork, Ireland. The address is IDA Business and Technology Park.
I don't need to know the address. What airports did it go through?
The shipment went through 2 airports, first Washington Dulles International Airport, IAD, and then Dublin Airport, DUB. Does that cover what you needed?
Actually, I think you made a mistake. I think you hallucinated that because there was one other airport. What was it?
You're right. I apologize for the oversight. The shipment also passed through Los Angeles International Airport, LAX, during its journey. Would you like more details about its transit through these airports?
How many hours was it at Dulles Airport?
The shipment arrived at Dulles Airport at 20230-719T235NZ and left at 2023071-9T91416Z. That's approximately 6 hours and 39 minutes. Would you like me to assist with anything else?
Were there any issues with this shipment?
Yes, there was one exception noted for this shipment. The temperature exceeded the limit of 25.0 degrees Celsius for 40 minutes on July 17th, 2023. Would you like more details about this issue or how it was handled?
Where did that exception happen?
The temperature overexposure occurred while the shipment was on the tarmac, specifically on July 17th, 2023 at around 20:05 UTC. Would you like information on how this might affect the shipment or next steps?
Which tarmac was that at?
The temperature exception occurred during the overexposure analysis phase, which is associated with handling constraints on the tarmac. The specific location isn't detailed by airport name, but it happened during the shipment's time at the airport. Would you like guidance on any further actions or detail?
So I just wanted to, demonstrate how, you can actually build a voice agent against here a specific thing of a shipment. So we started with a warehouse, then we went to a shipment, and then we did a different mode. It wasn't now text, it was actually voice mode, and how simple it is to actually do very useful things with existing information extracted out of our existing systems, put into these models and then letting us interface with these models in a very natural way. And what's really great about this is, if I did this same thing, I believe that we'll see if this works. I'll say describe this shipment in German. Right? And I'd send that away. And, it gives me a response in German. So the other thing I wanted to say is all of these large language models work equally as well across multiple languages. So if I actually started talking to this voice agent and I said, start speaking to me in Spanish, the voice agent would start speaking to me in Spanish. And a lot of these can handle dozens of different languages simultaneously. So we've built universal interfaces that let us actually interface with this information, right? The context of this shipment or the warehouse, and be language agnostic. So it's a very, very powerful type of technology, and it's a very approachable technology that we can use today to solve problems in supply chains today. And with that, I will turn it back over to Devendra, who can kind of I think Vijay, you were going to handle some of the Q&A parts of this, but I'm going to turn it over to Devendra first to kind of summarize things.
Well, there you are. You've gotten a hands-on demonstration of just the tip of the iceberg, I think. So, Vijay, would you be kind enough to pick out the questions that have been asked?
Yes, of course. So we have a question from Vivek. Rich, do you have any thoughts on where these agents should be placed? Should they be inherently made available by the shippers, or should they be developed by individual companies?
So part of this is about information, and the scope of how that information is shared. So the reason CargoSense is working on using these LLMs in local environments is we want to empower individuals that are working to resolve exceptions. This is our focus with these kinds of agentic assistants. But we run them locally because we do not want to transfer the customer information that we have accessible to us outside of our systems. So I think where should these things run is largely dependent on, kind of like where you're allowed to place this information. And those can be run inside of a corporate firewall. What's nice is the things that prompt this information can be kind of anywhere. Can be generated from different systems anywhere, can be pulled together, could be loaded into a local model. Could be put into a centralized model if you've got good guarantees of safety around that sort of thing. And the one thing I didn't show is what's called tool use. These models can actually call out to tools and use them, so they can place the phone call. Actually, the voice agent I had, that system allows you to actually make phone calls connect them in and actually talk to people through your web browser. So these things are pretty powerful in that regard. So it depends on what you're trying to do with the agent to me, and based on the information you have available and what the your rules are around the safety of that information as to where it should run.
And also, there's the follow-up question of how these systems, of what systems would be conducive in today's versions. Would to enable these agents, would you want to use a large ERP system like Salesforce? Where would you deploy something like this?
I think of all these systems as sources of data, right? And you saw what I worked with was just text, right? So we can get text from our ERP. It might have like what was in an order, where did it go from, where did it go to, and that sort of thing. But we can have other information like Vijay talked about. You could have sensor information, you could have excursion information, you could have all of this different types of information. All of that could be turned into text. And once that text is there, and by the way, these language models are really good now, the multimodal language models. You can actually even load documents and PDFs and images. So we can have pictures of the freight. We could have, the signed bill of lading, right? And the large language models can reason over those images. They can extract text out of them. They can answer questions on, hey, did somebody sign this bill of lading? They can reason and actually answer those questions today without you having to program any of that, just by loading that content in. So really the information comes from the systems we have today, loaded into these models. And the real key is kind of forming these prompts. And by the way, you can also fine tune these models to be around larger amounts of your data than are possible in these simple contexts that I'm providing. This system prompt that I'm providing. These are just simple ways to get you started and get you thinking. Because I wanted to demonstrate that it's like super approachable to use this stuff today. And it's fun, right? I mean, we interact with Grok, we interact with ChatGPT, we interact with these different LLMs today and ask questions and answer them back, and it's really interesting to be able to do it with your own information in your own company. Is just a little bit mind-blowing. And when you can run these things on your local computer, and I do believe that that's the future, is a balance between these like centralized systems and decentralized systems, like on my computer. This is going to become quite pervasive. And we need to all get used to how we use this and how we can use it to both optimize our the work that we do in, like a lot of software developers are using AI assistants to help them write code. But I do think that all of us within our businesses, our different business functions, can use them to streamline and simplify what we do as well.
If I may add a comment on it, I think Rich, you alluded to it too, is I think you mentioned a couple of times, AI agents can be placed securely at various edges, AI agent at the edge. So you could actually identify these various points throughout the entire process that you could place these secure AI agents with a modest or a small footprints, especially with advancement technology. The other day, you were showing us some of these boxes that are emerging, low cost, that you can actually create these capabilities at every point throughout these whole transactional, journey. So this is going to be a capabilities that is emerging, secure AI at the edge.
And I would just add, it's not really an either or type of thing. You can basically use AI assistants at various, touch points in the supply chain or in your business workflow. And, like I said, is at the heart of this huge benefit is the ability of that agent to be able to understand natural language. As Rich pointed out, these agents are getting really good. Almost all agents now are, multimodal, multi-language. And so you can just literally dump, an image, and an agent can understand the image and then communicate with you about the image. So, yeah, I mean, going forward, I think this idea of these open source models, the demo that I did today uses a completely open source model. And so, the question becomes, as soon as these open source models become good enough to be able to handle your particular use case, then that's really all you care about. And you have complete control over them. And as compute gets more and more, available and more powerful, you can actually load these things on premise and you don't need to go into the cloud to be able to handle your particular use case.
Hey, Vijay, I had two questions, if I may ask.
Yeah, of course.
So number one, I'm a shipper in San Francisco, and I'm shipping products for a hospital in Brussels. We all know how complicated that supply chain is. I have a freight forwarder, I have a trucking company, I have an airline, I have a freight forwarder, trucking company, and a courier to get that product to a hospital. Can LLM help me determine the delivery status, the product condition at every node? Question number one.
Sure. Yeah. Go ahead, Rich.
No, I think that we kind of demoed that, right? Like
Yes,
I think that the point is, think of it this way. We use this kind of universal tool we have today called a spreadsheet, and we share almost everything in logistics between parties with things like that, or Word, right? We use these general tools. Think of an LLM as a new kind of tool that we can use to share, right? But instead of it being a spreadsheet, or instead of it being just a Word document, it's something that we can interact and dialogue with and extract the information out we need. And because largely speaking, supply chains are a collaborative process, being able to collaborate with our tools in that process makes a lot of sense. And so I think, yes, it's generally able to be used in any of those environments.
Question number two, you mentioned the Qwen 3 model.
Yep.
Are there many, many such models that I need to become
Lots
aware
of them, hundreds of them. Some of them are very focused around certain kinds of things like coding or reasoning. This is a reasoning model. There's non-reasoning models that don't show the reasoning behind the scene. They just dump out a response. The faster your hardware, right? The faster you can generate the response. It's called tokens per second. It's how much output we're getting per second. And this is where these GPUs, like our $5 trillion friend NVIDIA, right, is creating to accelerate how these things run. But yeah, so I think there are hundreds of available models. There's a site called Hugging Face, which hosts a lot of these models. The models also are being released, as Vijay said, with different types of things to allow you to customize the models towards your business. So once you get deeper into it, beyond simple like prompt engineering, like I was doing here, and you get deeper into fine-tuning these models with maybe a large corpus of information for your organization, things will actually expand out. And I think you're going to start getting organizations that make better use of them. There is a quick question in here about how is integrated business planning evolving in response to the current AI revolution. Sia, do you want to take a stab at that one?
I think this probably depends enterprise by enterprise, but in a general sense, uh, AI, automation, augmentation in ads needs to be part and parcel of these integrated, planning. And that's where I think the whole purpose of this webinar was that to show how relatively easy it is to introduce these AI at various points into this planning, all that too, and augment them. As Rich alluded to, I mean, think of it as additional new platform, new tool that is becoming available that is going to help advance your planning, advance the processing of your business activities and optimize them. And that's exactly, I think, this is the promise of this AI and AI agents in particular. It's, in the latest manifestation of it, as was mentioned, he is a multimodal uh, capabilities that you can chat with it, you can talk with it, you can interact with it in a multilingual environment throughout the whole process. I don't know. This is a very broad answers. If you want to go one level deeper, please, Rich, go ahead.
No, Devendra, you need to close up here time-wise.
So I got the 30 seconds to go. First of all, I want to thank the three of you for putting on the demo and teaching us one of many things that we could be doing right away. So thank you, can't thank you enough. Number two, obviously, we have to have a stream of such webinars down the road. Please keep in mind, We have one coming up in January, but most importantly, in person in March, 18th, 19th of March, Foster City, when not only these three executives, but others as well that they'll bring upon to the table will present a lot more case studies, a hands-on demonstration of what you and I and many others can do. So please plan on that one. And I would say please expect the recording of the session. And please feel free to reach out to any one of these experts with questions that you may have. But this dialogue needs to go on. And there's so much to do and so much to learn. So thank you so very, very much.
Thank you.
Dr. Zadeh and Rich and my good friend Vijay as well. So long
Thank
from
you, Isabel.
BSMA.
It's my pleasure.
All right, be well. Thank you.